All right, today we are pulling back the curtain and decoding the secret recipe behind one of the most famous programming languages on the planet, Java. You ever wonder what really makes it tick? Well, it all boils down to this really unique architecture, and we're going to break it all down.
So let's start with the big question, the main puzzle that Java was built to solve. Think about this for a second. How can you write a program one time and then have it just work on a Windows machine, on a Mac, on a Linux server, anywhere, without changing a single line of code? I mean, how is that even possible? This whole idea, this write once, run anywhere philosophy, is exactly what made Java famous.
And the answer? The real secret sauce is hidden in three little acronyms: JDK, JRE, and JVM. Now I know, they might just look like a jumble of letters right now, but trust me, they are the absolute foundation for everything we're about to talk about.
Okay, first up, let's talk about the builders, the creators, the software developers. If you want to build anything in Java, you need the right tools, and that is where the JDK comes into play.
The JDK, that's the Java Development Kit. And it is the whole shebang. Seriously, it's the master toolkit. If you're going to write Java code, compile it, find bugs in it, this is what you download. You can think of it as the complete factory where all Java applications are built.
Now, to make this all super easy to remember, let's use an analogy. Let's imagine we're building a coffee shop. The JDK isn't just one hammer or one screwdriver. No, it's the entire coffee franchise kit. It's the box that gets delivered to you with everything you need to build your shop from the ground up.
So what's inside this kit? Well, you've got the compiler, which is kind of like your industrial-strength bean grinder. It takes the human-friendly code you wrote and grinds it into instructions a computer can actually understand. Then you have libraries, which are basically your recipe book. Tons of pre-written code so you don't have to reinvent the wheel. You also get a debugger. Think of this as your professional coffee taster, finding any problems before you serve a bad cup. And super important, the kit also includes the JRE, which is the actual coffee shop itself. And we're headed there next.
Okay, so let's shift gears. We've talked about the builders, but what about the customers? The people who just want to walk in and enjoy the coffee. What do the end users actually need to run the software you just built?
Well, they need the JRE, the Java Runtime Environment. And the key phrase here is minimum requirements. This isn't for building anything new. It's purely for running what's already been built. If you want to open a Java program on your computer, you gotta have the JRE installed. It's non-negotiable.
Let's go back to our analogy. If the JDK was that huge franchise kit with all the tools and blueprints, the JRE is simply the finished, polished, ready-for-business coffee shop. It's the place where the final product gets served.
And this is the most important distinction. The JRE has the espresso machines, the cash registers, the baristas, everything you need to run the shop and serve customers. But, and this is the big but, it does not have the bean grinders for new recipes or the power tools to build a new wall. You can run the business, but you can't build a new one.
So, we have the kit to build the shop, and we have the finished shop itself. But what's the engine inside that's actually brewing the coffee? This, right here, is where we get to the real magic of Java, the core innovation.
Meet the JVM, the Java Virtual Machine. And that word, virtual, is everything. See, it's not a real physical machine. It's a piece of software that creates a standardized computer inside of your actual computer. Its only job is to run Java code, and it makes sure that code runs the exact same way, whether it's on a Windows PC, a Mac, or anything else. So in our coffee shop analogy, the JVM is the magic coffee machine. It's the heart and soul of the entire operation. Every single one of our franchise locations, no matter what city it's in, a Windows city, a MacOS town, they all have this exact same magic machine inside. And this is how it all works. The Java compiler, remember that bean grinder? It doesn't make a specific drink for a Windows customer or a Mac customer. Instead, it creates these universal coffee pods, which we call Java bytecode. The JVM is that special machine that knows how to take one of those universal pods and brew a perfect cup of coffee no matter what kind of power outlet it's plugged into. It's the ultimate translator.
Okay, so we've met our three main characters, the builder's kit, the finished coffee shop, and that magic machine inside. Now let's put it all together and see how it all fits.
So let's just boil it down. Who needs what? It's really simple. If you're a developer, a creator, you need the JDK. It lets you build and run your code. But if you're a user and you just want to use a program somebody else made, all you need is the JRE. That's it.
The relationship between these three is probably best imagined as a set of Russian nesting dolls. At the very center, the smallest doll is the JVM, that's the engine. The next doll out is the JRE, which holds the JVM inside it, plus some other necessary bits. And the biggest doll, the one that contains them all, is the JDK. It has the JRE inside it, plus all those extra tools for building.
So the most important thing to remember is that these aren't three different things sitting next to each other. They're layers. Each one contains the one before it. The JDK is the big, all-in-one download for developers precisely because it already has everything else bundled up right inside.
Now, for decades, this run-anywhere architecture made Java an absolute titan of the industry. But here's a final thought to leave you with. In today's world of cloud computing, microservices, and containers, what happens when anywhere isn't a desktop computer anymore? How does this foundational idea evolve for the modern era? That's the big question now.